Assalamu alaikum, dear students. Today we will discuss the concept of limiting and excess reactant or reagent. Dear students, in any chemical reaction, there are two types of the reagents, two types of reactants depending upon their concentration. The one which is consumed earlier and controls the reaction will be the limiting reactant, and the one which left behind at the end of the reaction and is known as excess reagent. Students, first of all, we will discuss the concept of limiting reagent. Limiting reactant or limiting reagent. What is limiting reagent? The name indicates which limits, which controls, which stops the reaction. While discussing the concept of limiting reagent, first of all, we will define the term limiting reagent or limiting reactant. A reactant which controls the amount of product in a balanced chemical reaction and consumed earlier. Is known as limiting reactant or limiting reagent. The reactant or the reagent which is consumed earlier and controls the amount of product formed during chemical reaction is known as limiting reactant. For example, you are given a reaction in which hydrogen reacts with oxygen to produce water. In this reaction, 1 mole of hydrogen is used with 1 mole of oxygen to produce 1 mole of water. But actually, when we look at the concentration amount of these reagents, we come to know that 1 mole of hydrogen contains 2 grams and 1 mole of oxygen contains 32 grams, while 1 mole of water contains 18 grams. So you can say that from 2 grams of hydrogen and 32 grams of oxygen, there is a formation of 18 grams of water. If you look at here, there is one reagent which is completely used while the other one is not used completely, which is oxygen. In this reaction, the actual reaction is 2 grams of hydrogen plus 16 grams of oxygen is equal to 18 grams of water. This indicates that during the reaction, actual reaction is between 2 grams of hydrogen and 16 grams of oxygen to produce 18 grams of water. 2 grams of oxygen means 1 mole of 2 grams of hydrogen means 1 mole of hydrogen. 16 grams of oxygen means half mole of oxygen, and 18 grams of water means 1 mole of water. It means during the formation of 1 mole of water, 2 grams or 1 mole of hydrogen and 16 grams or half mole, 16 grams or half mole of oxygen is actually used in this reaction to produce 1 mole or 18 grams of water. Similarly, if we double the concentration, for example, in another reaction where 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. Here 2 moles, 1 mole and 2 mole. It is 4 grams, it is 1 mole which is 32 grams and it is 2 moles which is 36 grams. Now look at here, the total concentration is being used. So you can say that how much concentration, how much amount, how many moles of water are produced depends upon the concentration of hydrogen, moles of hydrogen which is used earlier, which is consumed earlier, and amount of water produced depends upon the amount of hydrogen being used in the reaction. So hydrogen being lesser in quantity limits the amount of product. So it is a limiting reagent. This is the concept of limiting reagent. Now, how can we find the limiting reagent? Calculation of limiting reagent. Calculation, or you can say that identification. How can you identify that which of the reactants is limiting reactant and which one is excess reactant? For this purpose, there are 3 steps. Number 1, calculate the number of moles of reactants, all the reactants present in the balanced chemical reaction, just like we have performed here, 1 mole, 1 mole, 1 mole, or 2 grams, 32 grams, and so on. So first of all, in order to identify the limiting reactant, you will have to find by performing these 3 steps. Number 1, calculate the number of moles of reactant. Step number 2, calculate the number of moles of product. How many moles or how much quantity, how much concentration of the product is formed, means calculate the amount or number of moles of the product. When you have performed these basic steps, then what will be the third step? The third step will be comparison between the moles of reactants and products. First of all, you have to calculate the number of moles of reactants according to the balanced chemical reaction. Then you have to calculate the number of moles of the product formed during the chemical reaction, the reaction which is in balanced form. Then after performing this, you will have to compare the number of moles of reactants and number of moles of the products one by one. For example, in the first step, you will have to compare the concentration of hydrogen with water. Then you will have to compare the concentration of oxygen with water. Then by comparing, you will be able to describe which one produces lesser quantity of the product, and the one which produces lesser quantity will be the limiting reagent. For example, we will consider this equation to perform the calculation. Let's suppose we have H2 plus O2 gives H2O. First of all, calculate the number of moles. Number of moles are given here. Number of moles given. Number of moles of hydrogen 1, oxygen 1, water 1. Now compare. According to the reaction, 1 mole or 2 grams of hydrogen are used and 1 mole or 32 grams of oxygen are used to produce 1 mole of 18 grams of water. Now, how can you identify which one will be the which one will be the limiting reactant? For this purpose, you will have to make a comparison. Comparison. Number 1, moles of hydrogen and moles of water. Then again you will have to compare moles of oxygen and moles of water. There are 1 mole of hydrogen and 1 mole of water according to the balanced chemical reaction. For the formation of 1 mole of water, 1 mole of hydrogen is required. So 1 mole of hydrogen, now we will have to calculate the mass in order to identify the quantity, because you have previously read equal number of moles may contain different number of grams. It means 1 mole of hydrogen contains different number of grams. 1 mole of water contains different number of grams. Now, again make the comparison here. According to the reaction, 1 mole of oxygen is used to produce 1 mole of water. Now find the mass. According to the reaction, in total we have 2 grams of hydrogen and 32 grams of oxygen to produce 18 grams of water. Now compare. From 1 mole or 2 grams of hydrogen, there will be 1 mole or 18 grams of water. Similarly, from 1 mole or 32 grams of oxygen, there will be the production of 18 grams or 1 mole of water. Look at here, the amount of the reagent which is completely used is 2 grams. And the amount which is not used completely is 32 grams. Because we have in total 18 grams, so we can say that oxygen is not completely used. We can compare it by using another example. For example, now students, consider another example in which 100 grams of calcium hydroxide and 100 grams of ammonium chloride react with one another to produce 1 mole of calcium chloride and 2 moles of ammonium hydroxide. Students, you are asked that 100 grams, which are 1.35 moles of calcium hydroxide, react with 100 grams or 1.87 moles of ammonium chloride. to produce these reagents. Students, you are asked to find how many moles or grams of ammonium hydroxide will be produced during this reaction. Got the point? You are given these values and you are asked to find the number of grams or number of moles of ammonium hydroxide formed during this reaction. Students, first of all, calculate the number of moles, and number of moles are given to you 100 grams. Divide 100 by calcium, molar mass of calcium 40 plus 2 oxygen 32 plus 2 hydrogen 74. In total, you will have to divide 100 by 74, which will be 1.35. So moles are given to you. Now, for this one, ignore 2. Just calculate the molar mass of NH4Cl. 1 nitrogen 14, 4 hydrogen 4 18, and 1 chlorine 35.5. 35 plus 4 39 plus 14 53. Grams per mole. Now divide 100 by 53, which will be 100 divided by 53. It will give 1.87 moles. So moles are given here. The first two steps are given. Calculate the number of moles. You are given the number of moles of both of the reactants. And now step 2, calculate the number of moles of the product. Now you have to calculate the number of moles of the product. How can you calculate? You can calculate by comparing the number of moles of reactants one by one with the desired product, which is ammonium hydroxide. How can you perform? Student, let's make a comparison of calcium hydroxide with ammonium hydroxide. According to the balanced chemical reaction, 1 mole of calcium hydroxide is used to produce 2 moles of ammonium hydroxide. So molar ratio will be 1:2. How many moles you are given? For calculation, you are given 1.35 moles for calcium hydroxide and 1.87 moles for ammonium chloride. So compare. According to the reaction, from 1 mole of calcium hydroxide, 2 moles of ammonium hydroxide will be produced. And from 1.35 moles, there will be 2 into 1.35 moles, which is equal to 2.70 moles. So we can say that from 1.35 moles of calcium hydroxide, there will be the production of 2.70 moles of ammonium hydroxide. Now, compare ammonium chloride with ammonium hydroxide. According to the balanced chemical reaction, there are 2 moles of ammonium chloride and 2 moles of ammonium hydroxide. So according to the equation, from 2 moles of ammonium chloride, there will be the production of 2 moles of ammonium hydroxide. So from 1 mole, it will be 1 mole. And we are given 1.87. So from 1.87 moles, there will be the production of 1.87 moles. Now students, you have compared the number of moles of both the reactants with the number of moles of desired product. And what is the outcome? Outcome is from 1.35 moles of calcium hydroxide, there is the formation of 2.7 moles of ammonium hydroxide. And from 1.87 moles of ammonium chloride, 1.87 moles of ammonium hydroxide are produced. Look at here, this one and this one. Which one is lesser? Which one are the lesser number of moles? These are actually the lesser number of moles. So the lesser number of moles are produced from this reagent. It means by definition the reactant which produces lesser amount of the product will be considered as limiting reagent. It means in this reaction ammonium chloride is limiting reagent. And we have read in the definition that amount of product formed during chemical reaction directly depends upon limiting reactant. It means the actual amount of the product formed during chemical reaction is this one. So you can say that there are 1.87 moles of ammonium hydroxide. You can convert it into mass by multiplying it with molar mass. How can you perform? Mass will be equal to moles multiplied by molar mass. Moles of ammonium hydroxide produced 1.87 multiplied by molar mass. What is the molar mass? 17 plus 4, 21 plus 14, 35. You will get the answer in grams. So you can easily find the quantity of the product formed during chemical reaction. This is the concept of limiting reagent. Hopefully you have got the concept. For any query you can ask the question. Thank you so much. Allah Hafiz.